Okay, so next thing we'll do, we'll review linear equations. Okay, so you guys know, right? We have three forms of them. The first one is called slope intercept. That's the one that you first see, right? Slope intercept. That's this one. Y equals mx plus b. Okay, the second one, my opinion, the least useful. So standard form. Okay, so this one looks like this. So ax plus by equals some number. And the last one that we'll use most often is called point slope. And it's this one. So it's y minus y1 equals, and here you have the slope, and then x minus x1. Right, so that x1, y1 is a point, right? So these are coordinates of a point. Okay, another important concept is slope, of course. And the formula we'll be using is that, traditional. So we have some kind of, right? So we have rise over run. So let's mark it as, let's do delta. Right? So that's difference between the y coordinates, right? Of those points between which we find the slope. Delta x, and that would be, it doesn't really matter, right? So it could be y2 minus y1. What matters is that the indexes need to be the same. So if you're subtracting y1 from y2, you need to do the same with x's. Okay, so we have a slope, we have those three different forms, and the one we'll be using is that last one, point slope. Anyway, let me draw a quick picture of just a straight line, and then we'll look at how we're finding that slope. Okay, so I'm getting better with drawing those straight lines. Let's take blue. And so we have a straight line. And then, right, we have 2 points on the line. So first one, second one, and coordinates. Let's do maybe this one, x2, y2, comma y2. And coordinates of this one will be x1, comma y1. Okay, so 2 points. And then, and you see that rise will be, and the difference between, and subtracting y1 from y2, and then the run will be subtracting x1 from x2. Okay, so that's that difference. Let me write that actually. So that was green. So this will be, see if I can do it this way. Okay, so the difference will be y2 minus y1. And then the difference here, right, for the run will be x2 minus x1. Okay, let me go back to 100%, or less. Okay, right, so you see what's happening, right? So that slope is just this distance here, right, the green distance over the red distance. Okay, so I don't know, what can we let's do an example, maybe a little more difficult than I was planning initially. Okay, so example 1. So find an equation. Maybe I can move it up. Here we go. It went too far. Find an equation of a line passing through 2 points. This is G. It's supposed to be G over here. Through okay. Well. Again, passing 2 points. Okay, so those 2 points are 1, -1, and then 4, 1. Okay, so yeah, so we'll start with slope, right? So slope was, the formula for slope was m equals, and we have that y2 minus y1. As I said, right, it can be either one. It can be y1 minus y2, and then the bottom is x2 minus x1, and then it's always good to label those. So let's label this one, maybe could be 0.1, so this is x1, right, and then this is x2, make it the same color, and then for the y's, this will be y1 and y2. Okay, so we go y2 minus y1, so 1 minus -1, and then the other one was yellow, so x2, which is 4 minus 1. I should have white color over there, right, so that I don't have to mess with this. Anyway, so what do we get? So we have 1 minus -1, so that's 2 divided by 3. Right, so slope is 2/3. So now we'll use that point slope formula, which was above there. So we have that. We'll use, when I'm trying to, let me write it actually. So y minus y1 equals m x minus x1. Right, so to figure out the actual equation in the form, in that slope intercept form, I'm using this point slope form. The names don't really matter, but yeah, so I can use any of those 2 points, whatever seems easier, right? Maybe I don't know, maybe the first point is easier. So we'll have y, and now comes the y coordinate of that first point, which is -1. Now we have slope, and we have x minus 1. Okay, so we'll have y equals, right? Now we have 2/3 x minus 2/3. And then, right, so this will be positive. So if I move it to the other side, -1. Okay, so y equals 2/3 x. And here we have, what do we have? 5/3, right? Minus 5/3. I hope it's right. Let me check it. Yeah, that's right. And so we found the equation of that line. That 3, let me just erase that 3, right? We don't need it here. I mean, now it's 2/3 over there. Anyway, so yeah, this is the equation of the line, right, that passes through these 2 points. Okay, what else we need to see here? Yeah, we have those, straight lines. I mean, one is vertical, the other one is horizontal. So, horizontal line. Sorry. Horizontal line, right? So, horizontal line, we'll have equation y equals a number, right? So, y equals maybe -2. Let's draw it quickly. Maybe extend this a little bit. So negative will be here, right? And that horizontal line will be like this. So this is our y equals -2. Yeah, for me, it looks like the problem is that, when I get to the bottom of the page, then my hand is touching the screen, right? And it somehow messes up my writing. So that was a horizontal line, and then we have a vertical line. Okay, so vertical line will have equation x equals a number. So let's write x equals maybe 3. And again, right, let me sketch it. X equals 3 will be a vertical line passing through x equals 3. Okay, so this is x equals 3. Okay, so let's continue. Yeah, let's do another example, or actually 2 examples. So let me move it. Okay, so example, I'm not sure. Let's see, example 2. Example 2, and it goes like this. So again, we'll be finding equation of just a straight line of a line that's passes of a line that passes through a point. This is O. And the point is 2, -1. And that line is parallel. To this line, 3y minus 2x. Equals -5. Okay, so parallel, right, means that 2 lines are parallel like this, right? So and we'll use the fact that 2 parallel lines have the same slopes. So we'll take that original equation, so 3y minus 2x equals -5. And to find the slope, we simply solve it for y. And so I'll have y equals, it's going to be positive divided by 3. 2/3 thirds x minus 5. Oh, not minus 5, wait. I need to also divide it by 3. Okay, so that's gonna be minus 5 thirds. This is 5. Let me make a better 5 here. Okay. I don't know if it's better, but let's leave it. Yeah, so we have our slope-intercept form. We see the slope, we see the intercept. And yeah, so when we find that line that's parallel, this is 5 again, we'll have the same slope, right? So we'll use that fact that these two lines have the same slope, and we'll use slope-intercept form. So that was y minus y1. So y1 is that negative 1. And then we'll have the slope, so 2 thirds. 2 thirds. So 2 thirds. And then we have that, right, that parentheses. X minus x1, so x minus, in our case, it's 2. Right, so again, right, so we'll have y equals 2 thirds x. And then I have minus 4 thirds. And it came from multiplying, distributing that 2 thirds, right, to both of them. And then we have minus 1. Okay, so y will be 2 thirds x. Minus, what is that going to be, 7? 7 thirds. Okay, so let me check with my notes. Let's see. Yeah, looks right. Okay, so yeah, what we found is an equation of a line, right, that is parallel to this line, but passes through this point, right, 2, negative 1. All right, so let's do another example. This time we'll do a line, basically the same. So example 3. So let's just write as above. As above. Okay, I don't know what that was. So as above. But perpendicular lines. And so perpendicular lines, so yeah, it'd be like this, 90 degrees between them. And when we're finding a line that's perpendicular to the other one, obviously the slope will be the same, right? So if I have slope, if I have some equation, right, and the slope is, let's say, m, right, so then the line that's perpendicular is going to have, this is symbol for perpendicular, is going to have a slope of negative, so opposite, and then reciprocal, so 1 over m. Okay, so in our case, if the original slope was 2 thirds, right, so let me write it here. Another page. So let me write that equation. So that equation was y equals I believe it was 2 thirds x minus 7 over 3. Right, so this is my original equation. Then the line that's perpendicular, so here slope was 2 thirds. And then the slope of a perpendicular line will be m equals negative, right? So opposite and then reciprocal, 3 over 2. Okay. Yeah, so basically the same thing, right? So we go, well, not the same thing, because the slope will be different, right? So y minus -1. And then on the other side, we have this new slope, -3/2. And then x and minus, that y value was 2 for that point, right? So we're using the same point. Okay, so let's clean it up and finish it. So y equals, what do we have? So -3/2x. And I'm distributing that 3/2, right? -3/2 to both. Okay, so what do we have? We have -3/2x, and then it'll be plus, right? I'm multiplying two negatives, so that'd be 6/2. So that's 3. See, I'm writing 3, right? Saying 3, writing 3, but it should be 2. And then, right, moving that +1 to the other side, so -1. So the final equation will be y equals -3/2 plus 2. Right, so 3 minus 1, 2. Okay, so what we found is an equation yeah, so this was what I said. This is not really the original, right? The original equation. This is the equation that passes through that point, right? So this should have been, the original equation was -5/3, right? It doesn't really matter, right? Because what we needed from that equation was slope, right? And the slopes of those two lines were the same. So we used that 2/3 as the original slope, which was actually the original slope. And then, right, we found the slope of the perpendicular line, and then we used the same point. Anyway, so yeah, so the last thing I'd like to talk about is domain and range. So let me write it here. Domain and range. What is domain and range? So domain is basically all the possible axes that we can use in a function. So let's look at maybe an example. Example, I don't know, 3. I hope it's right. So find domain and range. And range. Given an equation. So to find the domain from an equation, it's pretty easy, right? It's not easy. So the equation is f of x equals x squared. But it's pretty straightforward. We just kind of think, are there any x's that we cannot use, that we cannot substitute in for x? Right? And the answer, this is a polynomial, so the answer is no. Right? We can use any x. So domain will be all real numbers. Right? So we can write it like this. We can maybe write it in interval notation, so from -infinity to +infinity. To find range, well, we need to graph it. So let me graph it on the next page. Okay, so let's just use regular pen. So I hope you guys can graph it. It's just a regular parabola, y equals x squared. Use a different color. So this is y equals x squared. And right, to find the domain from, we already know what the domain is, but to find the domain, you would, project all the whole graph, right? We would project all the points from the graph onto the x-axis. And then you could be thinking, well, what part of the x-axis is covered? Well, actually, the whole x-axis is covered, right? So that was our domain. Let me write it again. So domain was all real numbers. But now for range, we do the same thing, but we project the points onto the y-axis. Okay, all the points, the whole graph. Basically, we squeeze it against that y-axis. So yeah, after we've done it, we see that the range, right, will be starting at 0, right? So that 0 will be covered, and then the positive part of the y-axis will also be covered, right? So range will be from, maybe we could write it like this, interval notation. So it will be from 0 to positive infinity. We can also write it like this: y is greater or equal than 0. There are a couple other ways we could write it. But yeah, any of those two will work. Okay, let's do another example. And that, maybe, what can we do? We could do, so this will be example 4. How about, I'm not going to write this whole thing. It's just, I'm just going to write the function. So f of x equals square root of x. Okay, so yeah, similarly, we could think about the domain, and when you have a square root, right? I hope you know that you cannot, to get as part of our range, for range to get, or for y's, right, to get regular numbers, real numbers, not complex numbers or imaginary numbers, we have to use, in this case, positive x's. So whatever is under, after you do your computation, whatever is under the square root needs to be a positive number. Okay, so yeah, so let's think about it. So for domain, right, I can see that the green, yeah, that I can put 0, right? In for x, I can substitute 0 for x, and I can put anything that's greater than 0, right? So domain will be from 0 to infinity. And then for range, yeah, same thing. Let's graph it and see what's happening. And I hope you know how the graph looks like for square root of, let me try again. So it's a square root of x. And so we could just kind of plug a couple numbers. So for 0, I get 0, right? Need to take a different color, maybe blue. For 0, we get 0. For 1, square root of 1 is 1. Square root of 4 is 2. And then we could keep going, but we already see what's happening. Okay, so we have our graph. This is y equals square root of x. And yeah, same kind of idea, right? We project, we squish the graph against the y-axis, and we get our range. Right? So we see that the part of the y-axis that's going to be covered is from 0 to positive infinity. Okay. I don't know, you might be wondering, okay, well, how can we have, right, square root function where I can actually plug in negative numbers? Well, we could have, for example, something like this, right? So let's have another example. So example, see, I'm losing track. Example 5. Okay, so example 5. So again, right, so let's do maybe something like this, so something more difficult. Maybe negative x plus 2. Okay, so in this case, if I put, right, negative numbers will definitely work, right? If I start putting them, and some section of the number line would also work. Of the positive side of the x-axis would also work, right? But let's. I think if we have, right, some kind of an expression here under that square root, maybe we could solve an inequality. So negative x plus 2 needs to be greater or equal than 0. Okay, so the way I solve those is I would actually add x to both sides. So that would be 2. Or move the x to the other side. X. So now let me rewrite it in like when x is on the left, right? The way we want to have it. So you see, right? So this is the domain, this is the solution. Let's see. So right, domain. So we could write it like this. X is less or equal than 2. Or we can write it in an interval notation. So that would be from negative infinity to positive 2. Right, so you can always check it. Right, so pick a couple numbers from that interval and see if they work. Okay. Yeah. So. Yeah, that's basically the end of that 1.1 of that section. And let me just give you like a longer problem for practice. So for practice, let me write it here. We have space. Yeah, only one problem. So let's do the function or whatever, the expression or the relation that we have. X equals y squared minus 9. And yeah, for the first one, find x and y intercepts. I'm just going to write find intercepts. Then B will be find determine symmetry. And then C, is this a function? Yeah, so yeah, figure out if this is a function. And then, well, start with the first one, right? So find intercepts, and I'll give you an answer. Answer is no. It's symmetry, and then is this a function? So for that last question, yeah, can you tell why this is not a function? Because actually it's not a function. So intercepts. So for x-intercept, it's going to be, I have negative 9, 0. Okay. For y-intercept, I have 0, 3. 0, 3. And 0, negative 3. Do we have space there? Barely. Anyway, negative 3. And then symmetry is with respect to x-axis. And this is not a function. Not a function. Yeah, so can you come up with some answer why this is not a function? I know I didn't explain it, what a function is and what is not, but you can figure it out. All right, that's it. So that's the end of 1.1.